Recording is rolling. It's Friday, March 7th. We're going to put these wheels today. Put these wheels together today. On this side is Newton's wheel. On the side is Benham's wheel. So here's the model we're aiming for. By the end of class, you'll be able to do this. So I can wind this up. And when I pull the string taut, it's going to spin. Now the Newton's wheel, the faster you get it to spin, the better it works. The Benham's wheel, I found like there's an optimal spin rate. So maybe an optimal angular velocity. How about that? And now this is one that works better in person than through a screen. Like looking through the camera through the screen, it's like, it works. But 2 feet in front of my face, ooh, I can see some colors emerging. Of course, the colors aren't really there, but that's the purpose, to show that with just black and white, you can sort of create the illusion of color in your mind, just where colors created. Okay. Before I get to that, let's look through my posters. There's one that I hadn't actually put in front of the camera screen the last few days. So let's look at the whole electromagnetic spectrum. So you guys know this is a transverse wave. These are waves that can travel through the vacuum of space. It's radiation. And they're all part of the same phenomenon. These all travel at the same speed, which we call speed of light. That's what the C is right here. And oh, look at this. It's the wave formula. Speed is wavelength times frequency. It's a special kind of speed. It's the speed of light. Okay. Oh, no, from left to right, we got radio wave, microwave, infrared, visible. That's what your eyes can see from red to violet. Ultraviolet, X-ray, and gamma ray. Speaking of this visible range right here, it's what your eyes can detect. Now, different animals can see into different parts of this. So some animals see a little bit into infrared. Some animals can see a little bit into the ultraviolet. Right? So if you had like bird eyes or something, right, the world would look a little bit different. Right? You could see things that you can't see with human eyes. Right? Different parts of the spectrum, even though they all travel at the same speed, they do have different wavelengths and therefore different frequencies. So they can travel through different materials, right? Different material properties. When we get to quantum mechanics, hold on to that idea. We'll circle back to that idea. Like, guys, for example, can light waves travel through these walls and through the ceiling? Can light waves travel through? Not through the walls, right? That's why you can't see through the walls. Okay. What if you had a radio, like a radio receiver? Could you turn on a radio and have radio waves could travel right through the ceiling? You could pick up radio signal. Yeah, so that would work. Okay. How about that glass window over there? You guys see that glass window? Can visible light travel through that glass window? Yeah, that's why it's transparent. What about ultraviolet? What do you think? Suppose you're on a long car trip. You're traveling all the way to California, and some of these days it's super hot and bright and sunny. And guys, do you need to wear sunscreen inside your car on a long road trip? No, no, because the windshield and the glass windows will block this ultraviolet. Yeah, so there. So food for thought there. All right, let's get back to these wheels though. So you guys each have a template. You guys got templates. So first thing, let's cut out these discs. Cut out the discs. Oh, while you're cutting out, just something to keep in mind, if I go back to one of these models, is at some point we're going to need these spacers right here. So I'm going to use some of this excess margin. You guys see that there's some excess margin here to cut these spacers. Now, if you don't have enough margin or you cut it wrong, that's okay because I did put some blank card stock out. So, and that's what these are printed on, right? So, well, if you're watching this video, then this is not regular paper. This is card, right? Which works better for this type project. Right, so same thing for the spacers. Right, if you use regular paper, it's a little too flimsy, but if you use this card, ooh, that's gonna work really nice. I got a couple of wheels. Walk around and check on you guys. A couple of wheels, couple of wheels. This.
Halfway, 4 weeks after. Okay.
So looks like you guys got the discs. Now, while we're cutting this card, working with the scissors. There, this one. Like so, you guys remember these spacers right here, right? Now, if I pull this out straight, it looks like a rectangle shape. So I'm going to cut 4 rectangles, and we'll fold these into accordion shapes, and that'll act as the spacers. Oh, I need to tell you guys why there's spacers at all. Because if you don't have the spacers, here's what happens. If you just have these 2 discs and you glue them back to back like that, then after I push the string through and wind this thing up and pull the string taut so it wants to spin, it doesn't see if I don't have the spacers there, it won't actually spin about the axis it's spinning about right now, like it's supposed to. Right? Instead, what it's going to do is it's going to flip and it's going to try to spin along this axis, which is no good, right? That would be pointless. Okay? So if you wanted to spin about the axis going through the center of the disc this way, like it's supposed to, then that's what you need the spacers for. So let's make these spacers. Now, really, I just need 4 rectangles that I'm going to fold into accordions. So see what margin do I have to work with. Again, if you don't have a big enough margin, then just go ahead and find some cardstock. I did cut out some blank cardstock. But this looks like... oh, here it is right here. So this looks maybe 3 centimeters wide. So here, I'll make a mark at 3 centimeters, 3 centimeters. Okay. And how about 1.5 centimeters? Right, that's good. Half of that. Okay. And then how long should I make this? How about if I go, maybe I'll just use the full width of no. Here. I'll go 10 centimeters long. So 2 of those give me 20 centimeters. So there's the 10 centimeter mark there. There's the 20 centimeter mark here. Okay. So I just outlined 4 rectangles. Now, my rectangles are 1.5 centimeters wide each and 10 centimeters long each. So 1.5, 1.5 makes 3 there, and 10 makes 20 that way. Here, cut these out. And it is you do want all 4 rectangles to be pretty much the same size as each other, so that when you glue these on, your model will be symmetrical about the center, so that it's not going to be weighted one way or another. Okay. If your whole project is symmetrical about the center, like radially symmetrical, so that the center mass is also the geometric center, then it's going to spin really nice. So we got 4 identical rectangles, 2 discs, 4 rectangles. Walk around and check on you guys. Yeah, that looks pretty good. Pretty good.
That's it. What's back for each of them? 10 centimeters.
So I did 10 and 10 and 20. So you go like 10 and 10. So you got to
And how different? What is the weight of it?
I did 1.5 centimeters. We go 1 or 2. Yeah. As long as all the rectangles are the same.
So here's the model we're going for right there, to the side. Since you guys just cut off the rectangles, here, I'll go ahead and start folding these into accordions. The way I'm gonna do this is fold in half a second time, fold in half a third time. Okay. Now it looks a little tiny like that. So just hit half, half, half. Guys, what is 2 to the power of 3? 8. Aha. So when I undo this, did it half and half and half. Oh, look, I got 8 panels, 8 panels. Now I'm going to go back and forth, back and forth, back and forth. Make it look like an accordion. Ooh, it's like an 8-panel accordion right there. Then just do that with the other 3 rectangles. Half, half, half. Not apart. Go accordion style with it. Back and forth, all the way. Guys, we're up to the accordions.
Oh, that's.
You just go back and forth. The accordion shape.
It's not, yeah, it's hard to be there, hard to take points off, yeah.
Oh.
I don't.
So it's simply there, with the accordions. Let's go back, forth, back, forth, back, forth. Yeah, those are good. Yeah, those are good.
All right. So I think you guys got the accordions. It's all good there. Yeah, let's get a length of string cut. We'll work the string later, but get it cut now. So I'm going to recommend cut a string that's maybe almost a meter long. So a meter long, that could be about 3 feet. Okay. Now your width from left to right, your desk, the width of your desk left to right is 60 centimeters. So make it longer than that. So the width of your desk is 60 centimeters. So make this longer than that. Here, so my string is probably about 90 centimeters long, something like that. Okay. So almost a meter long. Right. Everybody got a string that's almost a meter long? Okay. Now go ahead, just put this to the side. We'll work with the string later. Okay. Let's have that right there. Yeah, you guys know meter stick, right? Here, you guys know meter stick. You got some meter stick circulating. So I got a meter. I got a couple of meter sticks. See how long? Got right there. Yeah. Right there. Oh, that's a meter. There you go. Look at there. There.
Yes.
What's your? Oh, no. That's okay.
No,
Exactly.
by the time we get to the string, you're gonna need to push the string through these little pinholes here. You guys see those little pinholes? So, I'm gonna mark and punch those into the disc. Now, I want the pinholes to be the same on both discs, right, on both sides, so that the holes align when I glue them together. So I'm thinking ahead a few steps. Okay. So I'm gonna measure these out. Oh, this from the center, I'm gonna go half a centimeter each way. Go half a centimeter that way and half a centimeter that way. So the distance between the two holes is 1 centimeter. And then the center of the disc is right between them. Okay. Same thing on both discs. So that's the Newton disc. Let's do the Benham disc over here. There's the center. Go half a centimeter that way, half a centimeter that way. Bam, bam. Okay. All right, and then punch these holes. So punch this hole right here. This hole right here. All right, got a couple of holes right there in my Newton's wheel. All right, same thing on the Benham disc.
Just have the bottom. Breaking everything.
Each way.
You guys doing punching those holes. So half a centimeter that way, half a centimeter that way. Measurement. Same thing here. Half a centimeter, half a centimeter. Yeah. Punch those holes. Ah, that's it. Yeah. Guess you're right. Yeah, so this is pretty good. Okay, punching a couple of holes.
I'm doing this step.
Oh. Get one of these, right?
So do you measure two from centimeters each side?
Yeah, same amount each side. I did half a centimeter one way, half a centimeter the other way. So there's 1 total centimeter between the two holes.
It should be fine. Name a lot of what
You just punch a hole with a pencil.
Yeah. There.
Okay.
I punched a hole for the middle.
Yeah. It's not for you. Or, oh, you know what you can do? Here, you can just cut a corner of this. And if you need to glue this on the other side, like if you cut the holes too big, you can glue this on the other side. And then just punch a hole in this one.
Actually, I can fold it like that and then.
And something like that. So if you need to patch it. All right, everybody up to where I am here. I think it was good. It was good. I think we're ready to glue all these parts together. So I'm gonna flip one of these discs over, and remember these 4 spacers. I'm gonna glue on these 4 spacers. Guys, how many degrees should be between each pair of spacers? 90 degrees. Aha, 90 degrees. So I have a protractor here. You guys have some protractors. Okay. We're going to make these evenly spaced. Remember, the purpose of making the spacers evenly spaced is so that the center of mass of the whole project is right at the geometric center where you want it, so it'll be well balanced. So I'm going to put a spacer right there, bam. Spacer right there, bam. And then go 90 degrees That's bam, right there. And then 90 degrees on the other side, zero that out. Boink, boink, 90 degrees, bam, right there. Make sure that's lined up right. Right there. Yeah, it's pretty good, pretty good. All good there. Check. Pretty good.
Get the footballs on both ends, right?
Alright, so I marked the 4 spaces where I'm gonna put the spacers. I wrote down a dab of glue on each one of those.
Actually, since it's
And glue my spacers right in those places.
No, you see it, you see it.
Yep, those look evenly spaced. Yeah, you guys are pretty well symmetrical. Looks pretty good. All right. Trip around the room, checking the guys here. Yeah, you're gluing those. Yeah, so you're gluing all 4 spacers. I'm gonna recommend you mark on the disc the location before you glue it. So you get 4 marks down. All marks are 90 degrees apart. That way you know it's all symmetrical. No, either one.
Yeah.
Oh, yeah. Yeah, and then we'll get some rectangles, make them accordions.
Don't say.
Right. And then see there's a couple of holes punched in the middle. Okay, that's for, eventually we're gonna take a really long string about the song and string it through.
Say it,
Well,
please. Hold it.
you can kind of guess if you want to, if you measure it, then you'll know for sure it's gonna be balanced.
Did you use this one?
Why?
Okay.
That is true.
Okay, so this is my Benham's disc flipped upside down. I'm gonna take my Newton wheel and glue this on top. You guys, when you glue your Newton wheel on top, or Benham's disc if you do it the other way, make sure that these holes here are aligned with these holes here. Because remember, we're going to push the string through those holes that you poked from one of the back. All right, so here, I'm going to do a trial run first. All right, so I haven't put any glue on yet, although I kind of eventually need to. But are these holes going to line up? It's pretty good there. There. See how these holes lining up? Lines up there. Lines up there. Yeah, I can feel that. Endpoint going through. That's good. These are all lined up right there. All lined up. Yeah, let's go. All right, now the real run. Throw some glue here. So a little dab of glue on each one of these spacers. Take my Newton's wheel. Now, one nice thing about the glue is if you don't get this oriented exactly correctly, you can shift around a little bit. Okay, you got a few seconds before the glue's gonna dry. I take my pen again, make sure I find these holes correct. Okay, yeah, that's going through there. That's going through there. Yep, that's exactly where I want it. Right there. Oh, okay. I can see the light going through too. So, it's gonna press and hold this for a little bit. What I got to doing it here.
Okay. So there's some glue here. You on each one of these and press it down, and if you're not exactly line, then you'll be able to twist it a little bit before it comes.
We're getting real near the end here. So, guess remember that string you guys cut? Mine's about 90 centimeters long. We're there. Okay, I need to. Oh, here, I'll refer to the model. Yes, now I'm going to push the string through one pair of holes one way, and loop it around, make a U-turn, and push it through the pair of holes the other way. Ah, just like that. Okay, that's what we're going for. So, let me do that here.
Seriously, right? I debated this far, it's not gonna go now.
I've gone through, then loop it back and go the other way. I see it made a U-turn right there on that one. Okay. Then the ends of the string I can tie together. Okay, make a knot right there. Point. Okay, now the strings are tied together. Okay, so now it's one big loop. One big loop. Okay. Then pull it through on this side. Okay. Oh, it's gonna look like that. Okay. Okay. And then to wind it up, one end hold steady, the other end go like this. Okay, then this will wind it up. Okay. Now see, does this work? Oh yeah, looks pretty good right there. All right, so there's the Benham side. Check out the Newton wheel side. I wind it up again. Check out Newton's wheel. Oh yeah, that's working pretty good. Pretty good. There you go. So, walk around, help you guys, and that is a wrap on that project.